This is a probe working on the far side of the moon. If you could remotely control it to dig up 100 tons of helium-3, you'd be able to power the whole world for an entire year. But the moon itself blocks radio signals. The data the probe sends out simply can't reach Earth. So you, being clever, put a relay satellite between the probe and Earth. Let it act as a relay station, receive the probe's signal first, then forward it to Earth. But objects in space aren't standing still. The relay satellite would have to constantly follow the moon's motion to keep the same relative position, and that would burn through its fuel in no time. Then you suddenly realize, since the moon orbits Earth because of Earth's gravity, if you could find just the right spot to place a satellite where Earth's gravity balances the satellite's own centrifugal force, you'd solve the fuel problem easily. But now it's only synchronized with Earth. If it's not also synchronized with the moon, it can't relay the probe's signal. Then you, still being clever, notice that the moon has its own gravity. So between the moon and Earth, there must be a gravitational balance point. Put the satellite right there. The gravity from the moon plus the centrifugal force exactly cancels out Earth's pull. Then the satellite can stay put without using any fuel, moving together with both bodies forever. Congratulations, you've just discovered a special solution to the three-body problem, the Lagrange point. Right now, the satellite is on the near side of the moon, though it still can't get signals from the far side. So you extend that line further, and soon you find a second balance point behind the moon. Here the satellite feels both Earth's gravity and the moon's gravity. You know that at the same angular speed, the farther out you go, the larger the centrifugal force. So here, centrifugal force exactly balances the combined pull of Earth and the moon. That's the second Lagrange point. Now the satellite can receive the probe signal, but the moon is blocking Earth, still no way to send it back. So you think of another clever idea. Instead of sitting exactly at the point, make the satellite fly in a loop around it. Then split Earth's and the moon's gravity into components. You'll see that the centrifugal force balances the horizontal part of the gravity, while the vertical part acts as the centripetal force that keeps the satellite looping around. That's a second balance. Now the satellite can relay far side signals in real time without burning much fuel. Of course, Lagrange points aren't unique to the Earth-Moon system. They work just as well in the solar system. For example, the Webb telescope was sent to the second Lagrange point of the Sun-Earth system, where it's always in the shade, hidden from sunlight, so it can observe deep space 24 hours a day. And there aren't just two Lagrange points. Extend that line even further, and you'll find the third Lagrange point on the opposite side of the big body from the Sun-Earth view. That's behind the Sunday. This is the shadow Earth you often see in sci-fi novels. No use for real communication though, because signals can't get through. Now draw an equilateral triangle, and you found the fourth Lagrange point. Why does it balance here? You know, centrifugal force points outward, away from the center of mass, but the center of mass isn't the same as the center of the big body. Even a tiny object has mass. It can't orbit perfectly around the big body center. The center of mass is just closer to that center, not right on top of it. So the direction of centrifugal force tilts slightly to one side. That lets Earth's gravity, the moon's gravity, and the centrifugal force all balance right at the tip of the equilateral triangle. That's the fourth Lagrange point. Flip that triangle over, and you found the fifth Lagrange point. These two spots are super stable. Once an asteroid drifts in, it can hardly get out. They're great for observation. So besides these 5 points, are there any other Lagrange points waiting to be discovered? If someday you find an unexpected balance point in some new pair of celestial bodies, well, congratulations. That point would have the honor of being named after you.